Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes the difference between explained and unexplained deviation and how deviation gets translated into variation. Let's get started. To start with, let's use the shoe print height data set that we've been looking at in the past few mini lectures to understand the difference between explained and unexplained deviation. So here we've got a scatter plot. It's got our 10 data points located on the plot. And this red line here is our regression line. So this is the line for the equation that describes the relationship between shoe print length and height. This horizontal line here is the mean value for the y. So if we take all the y values from each of these data points and we average them out, we're going to get a line here at the mean value. So those are the two lines that we're looking at. And for any given regression line, we're going to have two possible choices for making predictions. And we've seen this before. Okay, we can use the regression model if it's actually good enough for making predictions. If it's not good enough for making predictions, then we can just use the mean value of the y. So we've got our two lines there, and you can see the equations for those lines there on your screen. Now, notice how each one of the data points, so all the 10 data points that we have in our set, are going to deviate from each of those lines in different ways. So let's look at an example point up here at the top. So this data point has coordinates 30.6, 181.6. So explained deviation is going to be the distance between the regression line and the mean. So if you look directly below that data point along a vertical line, just imagine a vertical line there, and then this distance here directly below that data point, that is the difference between the regression line and the mean line, that is what we call explained deviation. We call it explained deviation because we know where the mean value comes from, we know where the regression line comes from, and so the difference there can be explained. Contrast that with unexplained deviation. That's going to be the distance between the data point and the regression line. So here we've got an unexplained deviation, and it's called unexplained because, again, we know where the regression line comes from, but we don't know why our prediction is off. We don't understand why the actual position of the data point is off the regression line. So there's a portion there that's unexplained, and that's why this deviation is called unexplained deviation. Of course, you can either explain the deviation or you can't explain it, so there's your only two options. So if you add them both together, you're going to get the total deviation. And so that's just going to be the total distance between the data point and the mean line. So here's our different types of deviation, and we can calculate this for any given data point in the data set. So let's look at another data point down here near the bottom, 28.4 and 174. So the explained deviation is going to be the distance between the regression line and the mean. The unexplained deviation is going to be the distance between the regression line and the data point. And then, of course, the total deviation is going to be the sum of those two, the distance between the mean line and the data point. We can actually put numbers to what we just described with deviation. So looking at that top data point again, 30.6, 181.6, we can go directly below that to the point on the regression line. That's going to be 30.6, 178.2. And the respective point on the mean line, 30.6, 177.22. So these two lines are directly below that data point of interest. We can do the same thing with the other data point that we looked at over on the lower left. So explained deviation is going to be the distance between the regression line and the mean. So here in the first instance, we can get the difference between 178.2 and 177.22. That's 0.98. So that's going to be the explained deviation for that first data point. The second data point, we make a similar calculation and get a negative 1.91. Now, all the positive and negative means is it's just saying, which side of the line you're on. Okay? In the event that it's negative, that just means it says you're below the line, and that's what we see here with this second data point. It's actually below the line, and then this other data point up here is actually above the line. So that's all the positive and negative means. It's just a relative position of which side of the fence you're sitting on. Unexplained deviation, we can calculate in a similar manner. So in the first case, we're going to have 3.4. In the second case, we get negative 1.31. Total deviation is just the sum of those two. So we just add those together for each instance to get the total deviation. Okay. Notice that we don't necessarily have to take, this y-coordinate here and this y-coordinate here and then, subtract them out like we're doing here. We could actually just have taken the negative 1.91 and subtract 1.31, and that gives us the negative 3.22. Similarly, 0.98 plus 3.4 gives us 4.38. So there's different ways to go about calculating it, but in the end, it's the same sort of concept. This leads us to the concept of explained and unexplained variation. So we've just seen that total deviation is the sum of the explained and the unexplained deviations. We can write that mathematically like this. So using the definitions that we just saw on the previous slides, this is a mathematical representation for total deviation equals explained deviation plus unexplained deviation. Well, we can actually rewrite that if we take the sum of the squares of that total deviation. Okay, that will give us total variation. If we do the same thing with the explained deviation, that's going to give us the explained variation. And again, if we do the same thing with the unexplained deviation, that's going to give us the unexplained variation. And as it turns out, these variation concepts have the same relationship to each other that the deviation concepts had with each other. So we can just say the total variation is going to be the explained variation plus the unexplained variation. This actually has practical use when solving some problems. So let's take a look at an example run here real quick. So here we've got rankings for 202 U.S. universities, and they're recording information about each school. We're asked to answer the following questions. What's the explained variation? What's the unexplained variation? And what is the prediction interval with a 95% confidence level for rank using an 87% 6-year graduation rate? It's pretty simple to get out when we use StatCrunch. So first, what is the explained variation? Well, first thing we're going to do is, once the data is in StatCrunch, go to Stat, Regression, Simple Linear, select the data, and then we press Compute. And then out comes this wonderful results window. And you can see here the explained variation is in your ANOVA table. It's the sum of the squares for the model. So that first number there, just take it straight off the ANOVA table, and you've got your explained variation. Unexplained variation is right below it. Okay? So look there in the table, sum of the squares for the error. That's the unexplained variation. Of course, the total is right there below it. See the two that are just added together. And then the prediction interval with a 95% confidence level, that's just going to come from your prediction area. So go back into the options window, put in the 87 in the prediction of Y area, and then come back out and you'll get this prediction interval right here at the bottom below the ANOVA table. And that's really all there is to it. So it sounds complicated, but when it comes to solving problems, just get your ANOVA table, grab the numbers, and go. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.